We're good. Alright, so we continuing on in our notes on parallelograms. We're doing the properties of all the quadrilaterals right now. We're on the run by. And we've drawn our rhombus and we've marked up our properties for the basic parallelogram, the 5 properties. We marked our sides as congruent to each other. And all 4 sides are congruent, so it should be one single mark on all 4 sides. We marked our opposite sides parallel here and here. We've marked our opposite angles as congruent here and here, and then here and here. And then we also, we know that our consecutive angles are supplementary. And then we draw diagonals in that bisect each other. That's the thing we need to mark now. Since they bisect each other, that means that this diagonal is going to split this diagonal in half like this. Those 2 sides are congruent. And then this way, this smaller piece of the diagonal will be congruent to this smaller piece of the diagonal here. Alright, so that's the basic properties of any parallelogram. What makes this as a rhombus is these other 4 things. These other 3 things. All sides are congruent. We already marked the sides congruent. They're all congruent to each other. All 4 sides are congruent. And then the diagonals are perpendicular. When you hear the word perpendicular, what do you start thinking? You don't know? The diagonals are perpendicular. What does that mean in here? Anybody? Perpendicular lines form what?
What?
No, not necessarily. This will be the first class not to tell me perpendicular lines form what?
A 90-degree angle.
Thank you, Reese. Perpendicular lines form 90-degree angles. They're telling you that because they want you to know in the middle here you got all 90-degree angles. So in the middle there I got all 90-degree angles all the way around because these lines are perpendicular. That's the part that makes us a rhombus. That and the congruent sides. And then the other piece is diagonals bisect opposite angles. So I'm going to add this in for you too to help you out. So it says the diagonals, and this happens on the rhombus. The diagonals, they also bisect these opposite angles here. I mean, they cut them in half. So you have a full angle here, but then the diagonal comes in, it's going to split this angle in half congruently. They bisect angles. So this happens in the rhombus. So say if I say this angle right here is 66 degrees. On the rhombus, you can assume this angle on the other side is 66 degrees because the diagonals bisect the opposite angles. And the same thing happens on the other side. That means this angle has to be 66, and this angle will have to be 66 as well. I already know the angles in the middle are 90. On this, since I have these 2 angles, 90 and 66, I can find this other angle in all of the triangles too. Somebody find that one for me. Find the other small angle there. Somebody do that calculation real quick. Yep, I do it every class.
Sorry.
Somebody said 48. 24. 24 here. 24 here. 24 here. Yeah, the big angle would be 48. And 24 there. You see all these triangles are congruent to each other. All the small triangles in here on the rhombus are congruent, yes? Everybody see that? Alright. That's how the rhombus is set up. So that's the rhombus. Then the next one is the square. If you look down here with the square has all the properties of everything. All the properties we went through are listed for the square because the square has everything in it. So we need to draw a square for ourselves. I'm going to draw my square. Give me a sec. I'm going to mark that up too. Make this perfect square again. Oh, wrong color. Your chips is all in my video. Snack attack. What's he talking about? Come on, stay tight down here now. Stay tight on me. Stay tight. Real crispy like. I'm sorry, I gotta make this thing look good. Don't hate on my square now. Ain't no reason to do all that. That square crispy. Alright, so the square has all the properties of any parallelogram, plus all the properties of the rectangle, plus all the properties of the rhombus. It has everything. So we need to mark this one up. We're going to be marking this one up. Wow, like square, you should know, y'all already know all four sides are congruent. So the opposite sides have to be congruent. Y'all also should know that they're parallel, opposite sides here, here, parallel here and here. You should also know the opposite angles are congruent. All the angles in the square, y'all should know what they are. 90 degrees all the way around. And then consecutive angles are supplementary, which is true. 90 plus 90, 180. 90 plus 90 this way, 180. 90 plus 90 this way, 180. 90 plus 90 this way, 180. Consecutive angles are supplementary. Then it says the diagonals bisect each other, which they do. My diagonals that I put in are going to cut each other in half. Alright, diagonals that you put in are going to bisect each other, meaning they're going to cut each other in half, here and here. But the diagonals are also congruent, because that's the property of the rectangle, which is a property of the square. All four right angles, we got that already. Then you got four congruent sides, we got that already. And then we got diagonals that are perpendicular from the rhombus. These diagonals are perpendicular. So as we talked about earlier, reset, you should have all right angles in the middle again. Here, 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 and here you should have all right angles. And then the last thing, the diagonals bisect the opposite angles. So these diagonals bisect these opposite angles in these corners. If I bisect the 90-degree angle, how am I splitting it? I know, I'm asking. 45 and 45, right? So 45, 45, 45, 45, 45, 45, 45, 45. Got 45 degrees all the way around on this one. My next question is, if that's the case, look at all these small triangles in here. What kind of triangles are all these triangles? Identify them by their angles. I mean by their sides, I'm sorry. What kind of triangles I got? By their sides. Oh, y'all not. Let's be smart about this. What kind of triangles? Isosceles triangles. So all of them are isosceles and all of them are 45, 45, 90. 45, 45, 90, 45, 45, 90, 45, 45, 90. Actually, isosceles right triangles, you want to be real specific. So, that's us marking our properties. Let's go over here and use these properties to solve these questions we got. So we're on the back of our note sheet, doing the problems for properties of rhombus. keep the other sheet next to you so you can refer back to it. So we should be able to answer these questions. Number 5, it says ZY equals 34. YW equals 38. Write that in. Huh? Yeah. And then measure of angle ZXY equals 34 degrees. Angle ZXY. You need to mark that correct angle. So if you mark your stuff correctly, it should look similar to mine. Maybe not exactly. And then we go through and we find what they're asking us for. This is a rhombus, so you need to think about properties of rhombus, and it'll help you answer these questions. What have I not bothered yet? Isaiah, WZ. Yes, sir. $34. Why? What you mean? Okay, and you know that because you ain't gonna tell me what I want to hear. But yeah, you said it good enough. All 4 sides are congruent, right? That's good enough. I don't know why I put a degrees on there. Why y'all ain't correct that? That is not a degrees. Do not put no degrees on that. That is a side length. We need to skip ZV. We're gonna come back to that one. ZV is not as easy as y'all think it is. The measure of angle WVZ. WVZ. Oh, who can I pick on with this one? Chris, what's the measure of angle WVZ? One. Look at it. One WVZ. I ain't gonna mark it for you. You should know what it is for yourself. You know, Reese?
Yeah. 90.
Oh. Yeah, it is 90. Angle WVZ is 90 degrees. Did you tell him?
No. But I said it, like, I don't think he looked at it. I was just like,
WVZ is 90. I should know. All those angles in the middle are 90. This is a rhombus. Yeah. Alright. You about to try to tell me something about ZV? Ah, that'll be interesting. So ZV, Jamal, what's up? I can't hear you. No, that's not going to give you ZV. That'll give you WV and VY, but that ain't going to help me get ZV. Everybody, shh. Everybody pay attention on this one. I told y'all we never get rid of stuff. It always comes back, especially this. Alright, but I will go with what you said for 38 divided by 2. That's not going to help me get ZV. Well, it will, in a sense, but that's not what ZV is. So 38 divided by 2, what you got with that? I'm saying, what number did you get? Okay, so let me show you what 19 is. So if WY is 38, then that means VY is 19, and that means WV is 19. Both of those pieces. That has nothing specifically to do with answering Z. Well, it does. That's not the answer of ZV, though. That just means those two pieces are 19. WV and VY, or YV, however you look at it. That doesn't directly answer ZV for me. It helps me get there. So let me start painting the picture for you. I promise you we'll never get rid of it. Y'all don't believe me. I need to find ZV, this side right here. The way I see this, I see 4 small triangles inside of this rhombus. I see 4 small right triangles too. And in those right triangles, I'm looking at this one right here since it has ZV on it. In this triangle, what I see is I see a side that has 19, and then I see a side right here that has 34 on it. How would I find this missing side right here that I need ZV? Ain't that easy. What you about to say, Jamal? You about to say the same thing you said? No. These are not angles, but these are sides. You shouldn't be thinking about 180 at all. Come on. Ah, look at him. My boy don't came back. Didn't I tell you we would never get rid of it? Pythagorean theorem. Shh. On this one, we need to use Pythagorean to find this missing side of a right triangle. So that's what we need to do. I would label first just to help y'all refresh y'all memory on it. 19, this side, I would treat that as A. My missing side is ZV. I'd probably call that B. You would have to call ZY C because that's my hypotenuse. So that's just me labeling for Pythagorean to set myself up. Then after that, I want to write my stuff in for Pythagorean theorem. B, the side I'm solving for, is going to be what ZV is. So 19 squared plus B squared equals 34 squared. And then you got to do that math. I don't. I can use your phone if you need to. I know the numbers though. 19 squared, I should have got 361. I think. Plus B squared equals 34 squared, which I think they told me was 1156. So those numbers you should have got when you squared. Then from there we need to subtract 361. Cancels. B squared equals what? 795. 795. And then for now, I'm running out of space. I'm gonna come up here. B squared equals 795. And then I'm gonna square root. B equals. They said round to the nearest 10. Well, they didn't, but I think it is to the nearest 10th anyway. Anybody? 28.2. So in that case, B equals 28.2. So in turn, ZV equals 28.2. So on this one, 28.2 is ZV. The thing is, y'all gonna have to be able to identify when you need to use Pythagorean and use it when appropriate. I know. That's my worry. Next one. Find the measure of angle HGI. Let's mark that angle so we know what we're looking for. Angle HGI is this angle right here. Reese, angle HGI is congruent to what angle? Name the angle. I'm asking Reese. But you already done told him now, so yeah, it's congruent to Fij. Reason I want to know that because it wasn't nothing on HGI, so I need to know what to plug back into once I find my value of x. Well, now I know that these two are congruent, so I can plug back into this and get this. Yep. Alright, so now we need to find the value of x. To find the value of x, what equation are we going to write based on knowing that this is a rhombus and knowing the properties of a rhombus? Somebody impress me. Don't let Vincent answer all the questions. Oh, Nasir, you want to take this one? This is wonderful. That's not the equation I would write, because I don't think you know why you're doing that. Why you set it equal to 90? Huh? I agree, but I wouldn't set it equal to that. See, I don't think you don't know why you wrote it like that. That's what my issue is. Yeah, I agree. He said all the angles in the middle are 90 degrees. So let's try again. What equation would you write? Okay, so write the equation over. I can't hear you. There it is. Alright, so he says 7x minus 1 plus 4x plus 3 plus 90 equals 180. And now this ain't for everybody. But he wouldn't have been wrong what he first said, but he didn't understand why he said what he said the first time. Like, you could just say these two equal 90, but you gotta understand that's because you're leaving 90 out. So you really subtracting 90 from 180 and just leaving that out and setting these two things equal from 180 to 90. But if you don't understand that, you need to write it out full like I do. I do it like this anytime anyway, but some kids try to cut the concept short. But you gotta understand it to be able to write it the other way. If you don't, you'll never fail by doing this, adding all three angles together, setting them equal to 180. And then solving. That's what x equals, but we ain't asking for x. That's why we identified what we should plug back into at the beginning of the problem. Okay. So it seems like most of y'all don't solve, so y'all said x equals 8. And then from there, y'all need to plug back in. We already identified which one we need to plug back into. So the measure of angle HGI is equal to 4 times 8 plus 3, which is, what you said again, Faith? I'm sorry. 35 degrees. It's a 3. I want to move this to 8. Y'all work should be here. I'm just not solving equations for y'all no more. I make it too easy on y'all. Your work should be here that proves that x equals 8. Don't skip that part. You understand, Victor? Your work should be there. You shouldn't just write the stuff I wrote. You should have the work proving that you solved for x equals 8. Alright, slide on. Let's do the squares and be done. Squares, has all the properties. Number 7, it says AD equals 11, and then round to the nearest 10th. They only give you one piece of information. They do that on purpose because it's a square. A lot of stuff you should be able to assume and know already, just knowing that it's a square. I'm going to tell you right now, the first thing they ask you for is AC. That's probably the hardest thing to answer. It's probably the hardest thing to answer, so we're going to move, let's say that one for last. Let's do the other one next. Irvin, BC. Thank you. BC is 11. The measure of angle DAB. Chris, what's the measure of angle DAB? I'm coming back. I want to see if you learned anything. Come on, Chris. Huh? I can't hear you. I did. This is me coming back to you. It's kind of the same as the question that I came to you earlier on, bro. I thought you might have learned it by now. This is me coming back. There's a method behind my madness where I be wanting to see if you pick up on stuff. So I ain't gonna be able to come back to you after this. Reese, go ahead. Thank you. This is the one Reese answered for you before. The one I asked you and Juan about. It's the same thing, man. You got to be able to pick up on it. DAB is a square. DAB is the right angle. Go ahead, Jamal. CBD. Good. CBD is 45. Y'all didn't even need no information to know that. It's a square. CBD is the half angle. So half of 90 has to be 45 if this is going to be a square. Alright. The one that y'all going to have trouble with is AC. So let me paint the picture for you. AC is this diagonal right here. They want us to find the length of that. They didn't give us a lot of information on here, but they did give us enough to find this diagonal. Let me paint it out for you. So that when I see this, I see that diagonal, and then I understand that this is a square. So I know that this could be 11 down here, and then that diagonal right there could be part of this triangle that I'm going to create right there. Y'all know this is a right triangle, right? Alright. So what you think I'm about to use once again? No. Pythagorean theorem. Jesus. Oh, A, B, diagonal is going to be C. 11 squared plus 11 squared equals C squared. 121 plus 121 equals C squared. 242. C squared, square root. I forgot what that decimal was. C equals 15.6. So if C equals 15.6, in turn AC equals 15.6. There it is. Yeah, once again, y'all just need to be able to identify it so you know when to use it. Number 8, last one. This one not even hard. This one easier than the other one we just did. Number 8 says SW equals 2x plus 13. And then WU equals 8x minus 41. They want us to find VT. Let's talk strategy first. So we need to find VT. How are we going to find VT? VT is the same as what? I'm asking. Anybody? SU, right? Alright. So how would y'all go about finding SU? They equal each other, right? And once you set them equal, you're going to plug in, and then what would you do when you plugged in? I just want to talk strategy first before we do it all. Maybe we need to go part by part. Let's set them equal and find x first. Let's do that. So 2x plus 13 equals 8x minus 41. We know that because those are on the same diagonal, and that diagonal is bisected, so those are congruent. So we should know that this is congruent to this. Let's solve for x first, and we'll talk the rest of our strategy. What y'all say? 9. So x equals 9. I'm going to give y'all a second. Those who still solving. But there's nothing on BT. That's what I'm telling you. That's why I want to know what y'all was going to do. You could, but you can make it simpler than that for yourself too. Faith, what would you do? You had your hand up.
I was just
Disappointed. Juan, what's up?
Can you do
Can you like put one of them in parentheses, put one outside, and then plug back in?
There you go. Shh, Warren thinking today. Look at him. He said I would put one of the. He said he would put one of those in parentheses, put a 2 on the outside, then plug back in. Yeah, because you don't need to plug back into both. You can just plug back into one and times by 2. Y'all follow? He's plugging into one of them and times by 2. Which one you think I'm gonna use to? The simpler one, right? The 2x plus 13. Yeah, I'm gonna plug back into that one. So I'll go a different color. I'm gonna use that one, like Juan said. So for me, VT would be equal to, like he said, 2, and then in parentheses 2 times 9 plus 13. Follow the order of operations, though. Do what's in parentheses first. Like I said, y'all get in parentheses, y'all get 31. 2 times 9, 18 plus that, yeah, 31. And then double that up. VT equals 62. Yeah. Alright. Y'all already got the work. Y'all should be able to finish.